on inclined planes, which means friction on a slope. Yeah. So I'm going to share my screen. Now, again, you've got the notes that explain to you what forces are there when you have friction on an inclined plane. And this year, I'm going to demonstrate to you what forces act on an object when an object is on an inclined plane. The normal reaction force is always perpendicular to the plane. You're never going to have to resolve it. So the normal reaction force is already there. Then you remember when we did into the second module, we looked at how to resolve the weight, and it came to FC as well as Fs. FC as well as Fs. So on the notes here, it shows that FC is the parallel component of the gravitational force. Sorry, FC is a perpendicular component and Fs is the parallel component, and it shows the formula to calculate each. Okay. So these forces, these three forces are always standard when you have friction on a slope. Now, if there is no applied force, frictional force will position itself upward like that. That will be frictional force. Okay, so that will be frictional force. And then again, between the frictional force and the normal reaction, there's gonna be a total reaction force, TR, total reaction force. The angle of friction is still there. Okay, so this is the angle of slope. Then there is another angle here that is called the angle of rest. The angle of rest is the maximum angle that can be reached just before an object will start sliding down by itself without you pushing it. It's also called an angle of repose. Okay? So this is a different angle to the angle of slope. This is how we define it. We say the angle of rest or the angle of repose is the greatest angle of slope that can be reached before an object will start rolling down the plane without being pushed. Okay. So it's there. And then again, if we look at the equations that we use to calculate when you have friction on a slope, it will again be the formula to calculate frictional force, which is coefficient times normal reaction. Again, the coefficient equals to frictional force over normal reaction. And then the total reaction is still the square root of normal reaction force squared plus the frictional force squared. The angle of rest is calculated the same way as the angle of friction. It is tan theta equals to the coefficient. So the angle of rest is calculated the same way as the angle of friction. Okay. Then we can add here Fs. Fs equals to W sine theta. Now this is the angle of the slope. It's not the same as that angle. And then we can say Fc, which is that one, equals to W cos theta. So Fc is the perpendicular component of the gravitational force, and Fs is the parallel component of the gravitational force. Now, these are the forces that act on an object when the object is on a slope in general. Now, this is excluding the applied force. You can see we don't even have the applied force on here. So again, the applied force we will use equilibrium laws to calculate the applied force. So the question will tell us whether it's an upward force or a downward force, and the frictional force will switch around depending on the direction of the applied force. But these three forces are always the same. So let's look at an example that you also have on the notes, which is of an object that is now on a slope. It says here an object with a weight of 500 newtons is at rest on an inclined plane, the angle of 20 with an angle of 20 degrees to the horizontal. So this object is at rest on an inclined plane. So here is the inclined plane. The inclined plane is making an angle of 20 degrees to the horizontal. So this object is at rest. This object has a weight of 500 newtons. Remember, I said these three forces do not change. The FC, the FS, and the normal reaction force. Normal reaction force is perpendicular to the plane. FC is also perpendicular to the plane. FS is parallel to the plane. Those three forces do not change. Okay. So your force Fs is W sine 20 degrees, which is gonna be 500 sine 20 degrees, which we can work out. 500 sine 20 degrees, it gives us 171.01 newtons. That is force Fs. Then force FC is gonna be W cos 20 degrees, which is 500 cos 20 degrees. This equals to equals to 469.846. So we're still laying down our givens. Okay, Then they say the coefficient of friction is 0.4. We can write it down somewhere here. It's 0.4. Calculate the force required to push the object up the plane. It must push up the plane, up the incline. If the force makes an angle of 15 degrees with the plane, so the force itself also make an angle of 15 degrees and is pushing. Force F, if it's pushing, we make it push like that. Okay. So it makes an angle of 15 degrees. So this force is gonna have a parallel component as well as a perpendicular component. If it's pushing, the components are also going to push. So this component is gonna be F cos 15, and that component is gonna be F sine 15. Okay, then the frictional force will push down because the applied force is pushing up. So frictional force will be there. So the question says we must calculate the force required to push. So we're calculating force F. Okay. And then again, if you consider the parallel components, you're gonna use your equilibrium laws, which say upward forces are equal to downward forces. So upward, we have F cos 15, this one, and downward, we have Fs, this one, plus frictional force. Then we can continue F cos 15 equals to Fs plus frictional force. Frictional force is coefficient times normal reaction. Okay. Again, to get normal reaction, we're going to consider the perpendicular components. What do they say? Upward forces are equal to downward forces. So upward, we have NR, and downward, we have FC plus F sine 15 degrees. Okay. So let's substitute F cos 15 equals to Fs plus coefficient into, so this whole expression here is normal reaction. Fc plus F sine 15. Now we can substitute. What is cos 15? What is cos 15? Cos 15 is 0.966. And what is Fs? We worked out Fs over here. it's 171.01. What is coefficient? Coefficient is given as 0.4. 0.4. What is FC? We worked it out here. 469.846. What is sine 15? Let's work out sine 15 equals to 0.259. 0.259. So let's continue just to do the math. 0.966F equals to 171.01 plus 0.4 multiplied by 469 multiplied by 469.846. That one equals to 187.938 plus 0.4 times by, oh, this one has a T because it's because F. So it's F is here. It's F sine 15, okay? So it's 0.4 times by 0.259 equals to 0.104F. So 0.104F will come this side and become negative. So it's going to be 0.966 minus 0.104. It's going to give us 0.862F. Then this side we add this one and that one. 171.01 plus 187.938. So it gives us 358.948. Then we divide both sides by 0.862. 0.862. So F equals to 0.862. F equals to 416.413 newtons. So that is how you calculate friction on an inclined plane, especially when the force makes an angle like that. Thank you.